Good afternoon, children. The last area of this chapter is the inner transition elements, that is F block elements. D block element, it is finished. Some important compounds, that is potassium permanganate and potassium dichromate, its preparation, its that chemical properties and oxidizing properties with the examples, etc., will be removed by or excluded by CBSE. Okay, and these F block elements consisting of two series, lanthanoids and actinoids, 14 elements following this lanthanum and 14 elements following this actinium. Okay, and the lanthanoids resemble one another more closely than do the members of ordinary transition elements in any series. Transition elements, that is D block elements. ഓക്കെ, അതിനേക്കാൾ കൂടുതലായിട്ട് സം റിസംബ്ലൻസ് ഇൻ ദെയർ പ്രോപ്പർട്ടി. ദേ ആർ ഷോവിങ് സം റിസംബ്ലൻസ്, ക്ലോസ് റിസംബ്ലൻസ്, okay, close similarities between, okay, each and every element. They have only one stable oxidation state. They are not showing variable oxidation state like D block elements. Much more so it's especially these actinoids, you see so many radioactive elements are present in this series. So the studying or learning of the chemical properties of actinoid is very difficult. The chemistry of actinoid is much more complicated. Reason is that this question may come, the complication arises a wide range of oxidation state, and partly because of their radioactivity creates special problem in their study. This is the main reason. Their radioactivity, that is the nature or the property of radioactive nature is the main reason for the difficulties of the learning of chemistry of this actinoid. Okay, and lanthanoid, you see name, symbol, electronic configuration of atomic and some ionic states and atomic and ionic radii, lanthanum and lanthanoids. Okay, everything is given in this table. Let us go to the electronic configuration. Okay, electronic configuration with 6s2 common, okay, in the case of lanthanoids, but variable occupancy of 4f level. You see the table 8.9. However, the electronic configuration of all the tripositive ions are of form 4Fn. N is equal to 1 to 40. There are 14 F orbitals will be there. Okay, S2, P6, okay, D10 and F14 maximum. So the electrons may enter into this F orbitals maximum 14. So 14 F orbital will be there. So maximum 1 to 14 electrons can be accommodated in this F orbital. So the overall decrease in atomic and ionic radii from lanthanum to lutetium. Lanthanum to lutetium. Sorry. Okay, let us continue. So the electronic configuration common is 6s2. Okay, 4s level is that is different. The electronic configuration of all the tripositive ions are of from 4fn. 4fn means n is equal to 1 to 14 electrons will come with the increasing according to increasing the atomic number. Okay, atomic and ionic sizes of these lanthanoids. The overall decrease in atomic and ionic radii from lanthanum to lutetium is a unique feature in the chemistry of lanthanoids. Left to right. The decrease in atomic radii is not quite regular. It decreases, atomic and ionic radii decreases from, there are trivalent ions, plus 3 form. Their ions are in plus 3 form. So from left to right, the atomic and ionic radii decreases. Okay, but that decrease is not in regular manner. Actually, this contraction is of course similar to that in an ordinary transition series, and cause also same. The imperfect shielding of one electron by another in the same subshell, and the shielding of one 4f electron by another is less than 1d electron by another with the increase in nuclear charge along the series. Poor shielding effect and the higher nuclear charge. Okay, and there is a fairly regular decrease in the size with the increase in atomic number. So the effect of contraction of this lanthanoid series known as lanthanoid contraction, okay, causes the radii of members of this third transition series to be very similar to those of this second series, and the identical radii of zirconium, that is 160 picometer, and hafnium 159, a consequence of lanthanoid contraction. Actually, it must increase from left to right. Instead of that, you see, after zirconium, hafnium will come. Zirconium 160 picometer, hafnium 159 picometer. This is the main. This is the one of the important consequence of this lanthanoid contraction. Okay, and oxidation state of lanthanoids. Chemical properties will not come. Chemical properties of lanthanoids won't come. In the lanthanoids, the compounds are predominant. Lanthanoid compounds are predominant species. Occasionally, these plus 2 plus 4 ions also obtained. Generally, or common oxidation state is plus 3. And this irregularity arises mainly from extra stability of empty F, half-filled or completely half-filled or filled F subshell. Okay, the last electron enters into F orbital. That is why we called them as F block elements or inner transition elements. Okay. Here, their oxidation state, sometimes they will show plus 2 and plus 4 oxidation state, and this irregularity sometimes not a regular exploration, regular exhibit. This irregularity arises mainly from extra stability of empty, half-filled or filled F subshell. Formation of cerium plus 4 is favored by its noble gas configuration, but it is a strong oxidant. Okay, and reverting to common oxidation state, that is plus 3 oxidation state, and it can oxidize water. That is, it is a good oxidant, a strong oxidant, so it could reduce water. And also PR, ND, TB and DY also exhibit plus 4 state. Okay, UTTM 2 plus is a strong reducing agent, and changing to common oxidation state, that is plus 3 oxidation state. And the behavior of samarium is very much like europium, exhibiting both plus 2 and plus 3 oxidation state. Okay, these are the points related to the oxidation state of lanthanoids. Okay, and actinoids will not come, and chemical properties of lanthanoids also excluded, and similarity or comparison of lanthanoids and actinoids also excluded, and some applications of, that is, uses of D and F block elements given here. That paragraph you read it, otherwise we will do in our classroom. Okay, so this chapter is over. Next chapter is coordination compounds. Okay, so thank you very much for observing this class.